All right, Colts, we're going to do the 1.3 notes. These are the notes that I did in class. I'm not able to record while teaching at the same time, but I'll just talk you through them, and then I'm going to finish the examples that were not finished in class. So the objective of these notes is going to be to find the midpoint of a segment and to locate a point given on a fractional distance from the endpoint. So that one we might get to a little bit later. I have another worksheet that we're going to practice. But the definition of midpoint, so as you go through the YouTube video, just go ahead and pause it so you can write it down. But definition of midpoint is going to be midpoint of a segment is the point halfway between the endpoints of the segment. Okay? Sometimes it might be segments if there's maybe two intersecting. So here I have a line. I got those 2 points. Sometimes I have a midpoint there. This one specifically though, I'm going to talk about a segment. So I have my segment AB. And the midpoint, in this case, is going to be the M. Now, because I have these two brown tick marks right here, even though I'm not a super great artist, they are equivalent. AM is equivalent to MB, or congruent, as we would say, because of those tick marks, which signify congruence. So A is labeled X1, Y1, B is labeled X2, Y2, because sometimes we see them on the coordinate plane, and it'll help us to see a little bit easier where that midpoint will be located. Your midpoint, when you're finding one on the segment, it's going to be actually on the segment. So if there's a coordinate plane, make sure that point lands on that segment. So down here below, let me just highlight stuff as we go. We have the formula for midpoint. So it's going to be M is equal to X1 plus X2 divided by 2. And then we're going to take our Y's and do Y1 plus Y2 divided by 2. And if you notice, I labeled them XM, YM. So we take our two X's, we add them together, divide them by 2. And we take our two Y's, we add them together, and we divide them by 2. And so because I know that M is the midpoint, I'm able to conclude that AM is congruent to MB because we were given the information that M is the midpoint. If I just drew a super awesome picture, because I'm such a good artist, and I had the M in the middle, and it looked like it was in the middle, but I did not give you these tick marks, you cannot assume that it's the midpoint unless I tell you it's the midpoint, or if you found out like that perhaps this was 3 and this length was 3, and you would see that they're the same. Okay, so big thing in geometry, we got to make sure we don't assume. All right, moving on to our next definition. We're only going to do 2 for this section of notes, but it's going to be segment bisector. Okay, segment bisector is going to be any line, segment, or plane that intersects a segment at its midpoint. So I drew a plane, I have a line, it's kind of like a grayish-greenish color, and then I have the segment PQ, and then I have MJ. So all of those things, okay, so if I look here, here's my segment I'm talking about, right? And I have a line that passes through it, goes through M, that's the midpoint. I have MJ that goes through it, so that's a segment passing through that. And then I also have my plane here that passes through that point M. So in this figure, M is the midpoint of segment PQ and plane A. MJ, segment MJ and point M are bisectors of segment PQ. So we're going to go through some definitions. Not definitions, excuse me, some examples. So I'm going to go through and actually erase these guys so we can do it together. Hardest part of this one is going to be labeling it. So Jacinta is hanging a picture 15 inches from the left side of her wall. So here's our wall, right? So here we're going to be 15 inches away. And then the right edge is 37.5 inches. And she wants to put a nail to hang it, right? And we want that nail, or tack, or whatever it is we're going to be using, to be right there, halfway in between that picture. So we want to find the midpoint of the distance of that picture frame. So we're going to say 15 plus 37.5 divided by 2. Okay, if you need to, you can do 37.5 off to the side, 15, have 5 here, 7 and 5 give me 12, and I end up with 52.5. Okay, you will get to use a scientific calculator. So now we're going to do 52.5 and we're going to divide it by 2. And make sure you keep your units. Okay. Oh, I'm sorry. So I mischanneled. I can't do both things at the same time. And we're going to say at 26.25 inches. So 26¼ inches is going to be about where we're going to hang that. Okay. All right, moving on to the next one. We're going to go to number 2. For number 2, it's saying the temperature of the thermometer dropped from a reading of 25 degrees to -8 degrees. I'm going to give them the units Fahrenheit, just because that's what we use here in Reno, Nevada. And I want to find the midpoint of those temperatures. So I take those two values. I'm going to add 25 plus a -8 divided by 2. And I end up with 17 divided by 2. So it gives me about 8.5 degrees Fahrenheit. So the midpoint between those two. All right, our next one. So I'm not sure the best way, if it's better for me to erase it. Okay, first thing that we do here, okay, is I plot those points. S, so it's going to be -6, 3. And I gave myself a little piece of graph paper on here. If you have graph paper you're using to take your notes, if you want to just sketch a graph, go ahead and use it. It's just really hard when you're doing midpoint. And when you're finding distance, you just need to have a very accurate graph, because if you don't, you could maybe miss the line or you're not quite sure, so it's hard to guesstimate it. And then our value of t, or our point for t, is going to be at 1,0. So the reason I have you guys sketch it is because if I were to sketch this segment, I know that my midpoint has to be somewhere here in the middle-ish, right? We're not exactly sure, but that way if you get like, I don't know, you get your solution and you say it's 2.5, 3, you would see that 2.5, 3 is like way over here, and that's not even on the line. So just having that orientation of it helps us just to see if we're making any common errors. So we'll erase this circle guy. So I have my formula. It's really important we write our formula down, especially as we're learning it, so we don't forget it. And we're going to say we're going to add our x's, divide them by 2, and then we're going to add our y's and divide them by 2. So my x values were -6 and 1. Divide that by 2. And then my y values are 3 and 0. And I divide that by 2. So -6 plus 1, we end up with -5 divided by 2. And then 3 plus 0 gives us 3 divided by 2. So you could do -5 halves, 3 halves, but it's a little bit harder to see on the graph. So if you want, you can use your calculator and it will show you the decimals. So we're going to do -2.5, -1, 2.5, and then we're going to go up 1.5. So if you see here, that is dead center on that segment. So our midpoint in that case is going to be -2.5, 1.5. So I boxed both of them, the fractions and the decimals, because I'll take either way. But sometimes it just helps you to draw it, because if you have multiple choice, you can eliminate some of your options. All right. So now doing number 4, we're going to do it without the graph. Okay. If you wanted to, you could like sketch one and be like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and say, okay, I know A is way up here, and B is at -1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So it's here-ish, right? So you know that your midpoint should be somewhere in that area, right? So I know I need a positive x, and I know I need a positive y because of what quadrant it's in. Okay? All right. So we go through, we're going to add our x's. We have 5 and -4. So I add 5 and -4. And again, I wrote my formula up above. I divided it by 2. 5 plus -4 is the same as 5 minus 4, which is going to give us 1. We're going to divide that by 2. So we end up with just 1/2. And then I'm going to do my y's. And I have 12 and 8. So I do 12 plus 8 divided by 2. 12 plus 8 gives us 20 divided by 2, so it gives us 10. So now if I go back over to my graph, so I sketched before, but if I did about a half, and I went up to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's pretty close, right? To where my estimation was. and I would see that my midpoint is at 1/2, 10. All right, so finding the midpoint's actually not that bad. You can use the formula, but then we get to examples where I will give you the endpoint and the midpoint, and you need to find the other endpoint. So it's really important we use those formulas. So again, here in our example, okay, I'm going to erase these guys and actually do it with you. So I guess if you paused it, you could see it. But so first thing is I write down our formula, x1 plus x2 divided by 2, and then I say that it is equal to xm. And then I say y1 plus y2 divided by 2 is going to be equal to my ym. So I drew a little rough sketch off to the side, and I had my value. So just make sure you understand it. We're finding the coordinates of j. So we don't know what this one is. Okay. K told us it was the midpoint. And L has coordinates of 3, -5. So I plotted it at 3, -5. I plotted at -1, 2. Maybe my K is a little too far over, but we'll say it's -1, 2. So I just drew a sketch of where J potentially could be located. So looking at that, we know that our X value is going to be negative. Sorry, that negative is kind of sloppy. We know we need a negative X because of what quadrant it's in, and we know we need a positive Y. Okay, because any coordinates in this quadrant are going to have a negative X and a positive Y. All right, so we're going to use our coordinates that we have, and we're going to plug them in. So in this case, my x2 and my y2 are going to be yellow. So I'm going to substitute them in here, and then my xm and my ym, I'll say they're orange. So I'm going to substitute those in. So I still have x1 plus my x2 is going to be 3 over 2 equals my xm, which is -1. And then I'm going to say y1 plus y2, which is a -5. I'm going to put in parentheses, divided by 2, equals my ym, which is 2. Okay, a lot of students get stumped here and they get a little confused because it's a fraction and they're not sure what to do. So you just got to remember, in math, everything has an undo button. This line right here just means divide, and the opposite of divide is multiply. So in order for us to solve these, I want to get rid of these fractions. So I'm going to multiply, and I'm going to multiply by the denominator of that fraction. So the equation I'm trying to solve technically tells me what steps I want to do. So because I have a 2 down here, I'm going to multiply by 2. But what I do to one side, I have to do to the other side. Okay? So we'll do one at a time. I'll do the x's first, and then we'll do the y's. Give ourselves a little bit of space. Okay, so this 2 cancels with this 2. I end up with x1 plus 3 equals -2. Now we look at it and we're like, oh, that's a lot simpler. I'm going to subtract 3 on both sides, and I'm going to get x equals -5. All right, going down to our second one. Use a different color. I'm going to multiply by 2 also, so it cancels that. Make sure you do it on the other side, don't forget. And I'm going to say y1 plus, well, in this case, y1, and I have a plus and a minus, okay, which is just going to give me a negative. So I can say y1 minus 5 divided by, equals 4. I'm going to add 5 to both sides, and I'm going to say y1 is equal to 9. I'm going to move this up so it's not right on the seam. So we end up with our coordinate being -5, 9. So negative, positive. So if we go back and look over at our sketch, we wanted a negative and a positive. So if I were to roughly sketch this, the graph's not super pretty, but if I were to say 2, 3, 4, 5-ish, and then I went up 1, 2, 3, 4, 5, 6, 7, 8, 9, I feel like it's pretty feasible that if you look, if I had actual graph paper, it would show up a lot better. All right. How many more questions do we have? So I'm going to take this and split it so the video is not super long. then I'll finish the remaining questions on the next video.